Today's lesson is topic 6, lesson 2. We're looking at estimating solutions of linear systems of equations. And we are going to inspect just the equations to figure out what kind of solutions we're going to have. So we worked on this yesterday in our note sheet. So on your notebook paper, go ahead and pause the video and take a look at this warm-up activity. As you're working on this, you will see that this is going to give you the chance to analyze some of the components of linear equations that we'll be looking at in today's lesson. So for your learning goal, make sure and write this on your note sheet. You need 6.2 for the topic and the lesson, and you need to write today's learning goal. I can analyze and solve a system of linear equations. Then go ahead and pause the video and complete the warm-up. So to review what we discussed yesterday, when you solve systems of linear equations that have two variables like x and y, you are finding the intersection of those two lines. That is your solution, that point where those lines intersect. So solving a two-variable system has three possible outcomes, as we looked at in our note sheet yesterday. You could have one solution. One solution is when the lines intersect like they do in this graph. The equations of these two lines have different slopes. So we have this blue line is y equals x minus 1. So my slope is 1 because an x is the same as a 1x, and my y-intercept is negative 1. So from my y-intercept, this line goes up 1 over 1, up 1 over 1, up 1 over 1. So that's my blue line here. My red line is y equals 2x minus 3. So my slope is 2 and my y-intercept is negative 3. So my line, I can start my graph here at negative 3. That's where it crosses the y-axis, my y-intercept. And from here, I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. So I can see when I graph these lines that they intersect or cross in one point. So this one place where they cross each other, that is my solution of this system of equations, the point 2, 1. And I can know that just by looking at these equations, which is what we're going to look at today, and identifying the slope. If these lines have a different slope, then they're always going to have one solution. Sometimes, though, my equations are going to have the same slopes. But when they have the same slope, usually they will have a different y-intercept. So we need to look for same slope, but different y-intercepts. That means that my lines are parallel. Remember, like we talked about yesterday, my slope tells me the steepness of the line. So if my lines have the same steepness, then they're going to be parallel, which means they will never intersect. So as I look at the equations, I might see something like y equals x plus 3 and y equals x plus 1. Both of these lines have a slope of 1, but my blue line has a y-intercept of positive 3, and my red line has a y-intercept of positive 1. So because they have the same slopes, they both have a slope of 1, but different y-intercepts, I know that they're going to be parallel. So this is no solution. There is no point where those lines cross. My third scenario is I could have infinitely many solutions. And that's when my lines are exactly the same. I have two different equations that both describe the same line. So these equations would have the same slope and the same y-intercept. But sometimes we have to play around with them a little bit to see that they have the same slope and the same y-intercept. So this graph looks like the graph of one line, but I can actually graph this line from this equation and from this equation. So y equals x plus 2, that gives me a y-intercept of positive 2 and a slope of 1. So from my y-intercept, I'm going to go up 1 over 1, up 1 over 1, and that gives me this line. For my y-intercept, I could also go down 1, left 1, down 1, left 1, because a negative rise and a negative run still cancels to a positive slope. Now, when I look at this equation, 2y equals 2x plus 4, this is not in slope-intercept form. So I can't use this as my y-intercept because I haven't yet solved this equation for y. But what I do notice is that this equation, each term is twice as big as the equation above. So 2y is twice y, 2x is twice x, 4 is twice 2. So because I have taken my blue equation and multiplied each term by 2, these equations are going to graph the exact same line. So if I wanted to change this red equation into slope-intercept form, I would divide each term by 2. And that would give me y equals x plus 2, which is the same equation I started with. So those equations will have infinitely many solutions because every single point on that line is a solution of this system. All right, so let's take a look at some equations without their graphs and see what we can figure out from inspecting them. So we're looking for one solution, no solution, or infinitely many. So let's look at our first set here. Y equals 4x minus 1, y equals 4x plus 2. Right off the bat, I notice I have the same slope. The slope of both of those lines is 4. So same slope means they have the same steepness, meaning they're parallel. But I notice I also have different y-intercepts. So because I have the same slope but different y-intercepts, that means that these lines are parallel to each other, and parallel lines are never going to cross. So I have no solution to this system of equations. Let's look at our second set. Y equals 2x plus 4, and y equals negative x plus 1. So right off the bat, I'm noticing a slope of 2 and a slope of negative 1. So I have different slopes, which is fine. And I have different y-intercepts. I have a y-intercept of 4 and a y-intercept of 1. So I have different slopes and different y-intercepts. So that means that these two lines are going to have one solution. Because these lines are not parallel, so they are going to crisscross in one place, and that one point will be the solution for this system. Let's look at our third example here. X equals 3 and y equals 4. Remember, this is the tricky system because it doesn't look like my equations are in two variables. But I also remember that x equals 3 means that my x value is always 3, no matter what my y value is. So if we think about x equals 3 on a graph, this is my x-axis, and if all of my y values are 3, or I'm sorry, all of my x values are 3, no matter how high I go or how low I go with my y values, my x is always 3. So that gives me a vertical line. When I say y equals 4, that means my y value is always 4. So no matter how far to the left I go or how far to the right I go, my y value is always going to be 4. So that gives me a vertical line, and a horizontal line and a vertical line will always crisscross and have one point of intersection. So this would be one solution. Let's look at our fourth example. Here I have x plus y equals negative 1 and x plus y equals positive 1. So I noticed two things that are weird about this. This equation is in standard form. This is not in y-intercept form. See how all of my other equations are solved for y? This is kind of a special case here, so we can know that this one's kind of different. But I have slope-intercept form here because all of my equations are solved for y. And I like that because I can easily see the slope and the y-intercept, right? But now I don't have it solved for y. I have x and y on the same side. So it's a little harder to look at and understand. But here's what I do know. that x plus y cannot equal -1 and equal +1 at the exact same time. So I know that this one is going to be no solution. But to help us see that a little easier, let's go ahead and solve each of these equations for y. So if I want to solve for y, if I want y by itself, I have to get rid of the x. So I'm going to rewrite my equation here, and I'm going to start by subtracting x from both sides of my equation. So x minus x is 0, so all I'm left with here is y. And I'm going to put my negative x first and my -1 second so that it's in y equals mx plus b form. This is my slope-intercept form. And I can't combine an x and a 1 because this is a variable and this is a constant. So this is what this equation would look like. Now let's solve the second equation for y. Let's start by rewriting my equation. X plus y equals 1. If I want y by itself, I have to subtract x from both sides. That leaves me with y equals -x plus 1. So now that I can see both of these equations in slope-intercept form, I can see, all right, these have the same slope. They have a slope of -1, but they have different y-intercepts. Same slope means they're parallel. Parallel lines will never cross, so there is no solution to this one. So two ways you can see that. Let's take a look at our fifth example. Y equals 5x plus 4. Thank goodness we're back to slope-intercept form, so I can easily see my slope and my y-intercept. But on my second one, it's not exactly y-intercept form because it's not solved for y. I have 2y. However, I noticed that this second equation, each term is twice as big as the equation above. If I double y, I get 2y. If I double 5x, I get 10x. If I double 4, I get 8. That means that these equations are the exact same line. So this would be an example of infinitely many solutions. And if I want to, I can take the second equation and I can divide each term by 2. So that it is in slope-intercept form. And if I do that, I would get back to the equation y equals 5x plus 4, which is identical to my first equation. So then I know those equations both show the same line. Okay, our last example, we have 2x plus 3y equals 6 and 8x plus 12y equals 24. So kind of gross because these are not slope-intercept forms, so it makes it hard for me to see exactly what's going on. But even though they're standard form, I can see that 8x is 4 times as big as 2x, and 12y is 4 times as big as 3y, and 24 is 4 times as big as 6. So these equations are really graphing the same line. So if I can see that relationship between these, then I automatically know if it's the same line, then I'm going to have infinitely many solutions. So let's let you try it this time without graphing. Pause the video and try to decide if this is one solution, no solution, or infinitely many. Okay, two ways you can think about this. Since these equations are both written in standard form, I can't look at them and see my slope and my y-intercept because they're not in that slope-intercept form. But what I can do is look for a relationship between these two. So I see that 2x is twice as big as x, and I see that -2y is twice as big as y. But I see that 8 is not twice as big as 6. So if I take this second equation and I double it, I would get 2x minus 2y equals 12. And 2x minus 2y can't equal 8 and 12 at the same time. So this would be no solution.